Welcome to the Listen, Learn, and Lead series, where we interview the extraordinary leaders of Naval Postgraduate School. Today, I have the pleasure and the privilege of interviewing Dr. Alex Bordetsky. He is a professor of information sciences here at NPS, as well as the director of the NPS Center for Network Innovation and Experimentation, otherwise known in short as CENETIX. Prior to my talking with Dr. Bordetsky, it's very useful to know about his extraordinary background. So let me share that with you. Not only does he hold the dual appointments here at NPS, but he is a recipient of the prestigious Robert W. Hamming Interdisciplinary Research Award for the pioneering studies of collaborative technologies and adaptive networking, and the Fulbright Senior Fellowship Award for the experimental studies of unconventional maritime networking. He was the principal investigator for the renowned Tactical Network Testbed Maritime Interdiction Operations, the Academic Experimentation Campaign, which is now in transformation to the Littoral and Maritime Land Counter Weapons of Mass Destruction Operations Study. Professor Bordetsky has also been a research fellow for the Air Force Office of Scientific Research and the German National Center for Research in Information Technology. He was a principal investigator for various research projects funded by AT&T, Lockheed Martin, NASA, Sprint, the United States Air Force, and other leading institutions in the United States, Israel, and Russia. Prior to joining us here at NPS, Dr. Bordetsky taught at the University of Texas at Dallas and held the post of director for the Institute for Telecommunication and Collaborative Technologies managed by the California State University System. Dr. Bordetsky, what an incredible pedigree of intellectual and practical research and applications across the board with your extraordinary professional life. Tell us a little bit about yourself, though, if you would, and how you came to this place called NPS and your journey, please.
Admiral Rondeau, thank you for inviting me to this discussion and interview. And it's been a journey and a very interesting one. It's my good fortune to work for almost 20 years here at NPS as the Information Sciences and Space Systems professor.
And as a matter of fact, on the 7th of July will be your 20th anniversary, won't it?
Yes, ma'am.
Great.
It's coming soon. I can't believe it's already 20 years. Maybe because it was so interesting and so encouraging to work in here. I remember Professor Dan Boger, during concluding the search interview, telling me for how long he is here in this fine institution, and the reason he's here for so long is our outstanding students. And I eagerly accepted it, having no idea what exactly it means. Now I know, and I would like to simply repeat it. It's a privilege to work at NPS and go through the knowledge acquisition and transfer journey with our super achieving students.
Well, thank you, sir, very much. And so we are now in the CENETIX lab at NPS, and tell us about this space and how you and your students use this space, and about the NPS mesh networking study that began here.
Yeah, it actually began, if I may point it, in basically literal terms, began from the roof of this Pentagon, where this antenna put skillfully with Ingenuity Sparks by my colleague Eugene Burakov is now standing to get us connected to our first orbital node for studying networks. So it began from this roof when we stretched the network all the way out through 7 hilltops to Camp Roberts, about 100 miles from this place. Commander Ryan Blazevich had it as his thesis project. And that network set up a test bed. We were looking for, with our SOCOM sponsors, to start the studies of self-forming networks with unmanned systems. This is between 2004 and 2005, 15 years ago. It's been a completely novel subject, and that's how it started.
So some of those sponsors, can you talk about any of those sponsors that were helpful in that endeavor from the very start?
Yeah, from the start, we were fortunate to begin the whole endeavor of studying networks with Special Operations Command, with our great colleagues from the Lawrence Livermore Lab and Department of Energy, with the Office of Secretary of Defense Counter-WMD program, which brought us into the world of mesh networking with sensors, particularly sensors related to radiological nuclear threats.
So what does your work here in the CENETIX Lab tell you about what to look forward to for mesh networks? Tell me where you think this goes.
Well, it goes, we set it up as an initiative coming from the floor of Information Sciences Department to create that laboratory in the field environment, which helped us, together with our sponsors, to start the field experimentation endeavor. But those experiments needed networking infrastructure. So we studied by the way of scaled field experimentation that my colleague Dr. Ray Bittner now leads on such a great scale. So, and that put us in a very interesting position within the Department of Defense S&T community, that for probably a good 10 years, we became a hub for the researchers, operators, industry partners coming here to NPS and putting together innovative solutions or seeding them in a matter of days.
So I remember when you and I met the very first time was at GIFIX at Camp Roberts with Dr. Bettner there, and you were so engaged at what was possible here in the mesh networking work that you were doing. Well, you also, of course, know that NPS, because you led this also, it has a very strong space science program. And I understand that your team here now is planning for satellite launch soon, the CENETIX Orbital 1 CubeSat. Can you talk about that?
Yes, with great pleasure. I'm privileged to be the information sciences professor on the space systems academic group.
Yeah, okay.
And over time, it helped us to develop very productive collaboration. And my Fulbright scholarship goes exactly along those lines. I received it for exploring the first mesh networks in orbit between the small satellites. So that was the objective of my experiences. Before joining NPS in 2000, I had a privilege to work with Professor Robert Tweaks at Space Systems Development Lab at Stanford.
Yeah.
And that was my first. I remember operating the T-plate size first picosats built by the Aerospace Corporation in 1999, and we've conducted from the floor of Stanford Space Lab using the internet distributed ground stations. We've conducted the first very simple communication experiments with these picosats. That's what brought me in.
And isn't it exciting what now the commercial side and industry can do with the government that is exemplified by SpaceX? And so being able to do things with industry, the government, higher education, all in space, it's quite the new kind of frontier, isn't it, in many ways?
Ma'am, it is.
Yeah.
And again, not to pretend being immediately in that league, but in some way our endeavor, this is our satellite. This is the snapshot from the Firefly Aerospace Corporation. You can see the title, which is the Naval rocket tailing the trend started by SpaceX. It is a startup which attracted Marine Corps as a potential significant partnership in having least expensive, frequent launches of needed assets to the orbit. The Firefly rocket. So we were fortunate to receive an award from the Firefly Aerospace Corporation to launch our payload, which is the CENETIX Orbital 1 CubeSat with the tactical networking node for the Marine Corps small unit operations. By the maiden flight of Firefly Alpha rocket. It is 3D printed.
Wow. So, you know, it's interesting. You remind me of another time that you and I were in this room together with the Chief of Naval Operations, and you had this kind of sophisticated satellite conversation with our students. But then there was that, so you talk about the Marine Corps being so involved in Firefly and space and satellites, but on that same day, you had a Marine Corps officer who was also talking about what he had developed as a very small mechanism on top on the back of birds, of various kinds of birds, to be able to also acquire some signaling in the most tactically raw environments. So that your scan is not only about the sophistication of Firefly and space and satellites, but also making sure that you are attentive to the tactical needs of all of our officers and our students as they think about the entire space in which they operate. It's really quite an extraordinary thing. So NPS is becoming known as the new science and technology mesh networking hub, as you had talked about, but from underwater to orbit. What do you think is attracting the DoD sponsors to supporting the student-faculty studies of these emerging networks? What is attractive to DoD about this?
Our students. If I put it in very short words, while we are just working on launching the satellite, carrying on our unique very long-haul links-based node into orbit, our students, this is an example. I would like to show the title. This is the project that has been completed a week ago during our shelter-at-home phase of studying without coming to the lab environment or conducting partial field experiments, which we will typically do with our students. So they already put the emergence of this new node into the concept of literal operations in contested environment. That's their project.
Yeah.
How faster and more significant from the operational standpoint the results of engaging our students into the process could be. So they came up with a model that is already a comprehensive architecture model that two Marine Corps students and Navy officer created, and this is the ship-to-shore mobility and congestion reduction analysis, scalability factors, and maintaining this intermittent, short-living orbital node-based network, delivering the results.
That's quite remarkable. I know that you're very proud of your tactical network test bed for maritime interdiction operations. You want to talk about that in brief words?
It's been a remarkable endeavor. One of the first breakthroughs, you asked me earlier about it, one of the first breakthroughs that we've contributed to, so that through the very interdisciplinary effort across NPS colleague, done together with our colleagues from different departments, we've created first networks helping geographically distributed operators to manage their unmanned assets. And one of the most, with various applications, ranging from unique ISR missions to the direct action scenarios, which we recently played with our Polish Special Forces partners by taking the whole networking process into a short window of paratrooper during the descent. If it's picture the Polish paratrooper unit communicating while under the canopy with our maritime infiltration team already underway and coordinating their activities. And you brought up the reference, I'm happy to hear it, to Major Justin Murphy's project, to the short-living nodes of Falcon carrying on the networking node, and that goes on and on. The TNT endeavor allowed us to create an infrastructure for experimental studies.
Well, I think that what you talk about, though, is that it brings high science and technology to even backpacks on Falcons, and so that your work here is not only teaching the high concepts, but also the applications and of those high concepts to real things, and that's just terrific. A couple of more questions. So, and these are two, I think, important questions. You've led some extraordinary breakthroughs. Can you tell us a student story, a story about a student who you saw that extraordinary evolution of where he or she came from, and then developing something that was that led to a true breakthrough? Can you tell us a story?
Certainly. So let me start with Commander Ryan Blazevich. I brought up his name when we were discussing the origins of our study. He recently visited us. And what we were discussing, the support by his team, he is now the head of the Tomahawk program. It's a remarkable story in and of itself.
Yeah.
After his very successful service, discussing how can we use some of the assets that his team has access to study the projectile-based networks. So they're putting it on the scale in very different environment. Major Justin Murphy stepped aggressively against all odds. You know, taking what we did with the short-living projectiles, with slowly descending parafoils under the wing of the bird. That was one of the few times that I was skeptical that we are not going to make this project. He made it. Now it is in the center of studies of short-living nodes network. Captain Haley Nowak just graduated. She explored, together with my colleague Eugene Burakov, the emerging options of using the bursts of LED light underwater so that we can stretch our short-living nodes and links. This is the new direction we are pursuing, from the aerial assets supporting the ISR missions to subsurface divers. That's a significant breakthrough. And the Marine Corps Major Andrew Walker just graduated, and he created the first working with elements of artificial intelligence analytics hypernode that my colleague Rick Hayes Roth and I envisioned just in the theory of future networks 10 years ago. Now we have students coming and taking it to life.
That's great. Those are great stories, and I thank you for that. It's really very validating. Finally, the last question. So, you are an accomplished researcher, you are a senior professor, you are a beloved teacher and professor, one of our most popular, and you're a leader on this campus in the faculty and with the students. How would you advise one of your students if they were to ask you, Dr. Bordetsky, what do you think a leader should do? What is leadership to you? If he or she would ask that question of you, what would you answer to that student?
Between the lead faculty and students, I think it isn't such difficult to lead. We have exceptional students. They are the achievers with very strong motivation. Well, what good leader needs to provide them with the vision on where to go, because it is only such a short time they have at NPS to put their minds and sometimes hands around these new topics of study. Join the team of knowledge generating and knowledge transfer community and provide them with means. So two simple things: vision and means.
And means. That's a great way to end this. And I want to again thank you. You know, you talk about vision and means and so many other things. I heard a Marine officer say the other day that the students here are determined to be successful. They are determined to really study and be successful. I want to thank you, though, for inspiring that kind of success and that kind of determination. You're leading for us in science. You're leading for us as a teacher, and it has been a privilege and a pleasure to make you now part of our leadership and learning interviews here. And we thank you so much for all that you've done for this great institution. Thank you.
Thank you for having me, ma'am. It's a great privilege.